Okay, so I'm going to get started on the Chapter 8 review. This is short in terms of slides, but there are a good number of problems in here. And before we start, I want to make sure, I want to make sure everybody has access to a calculator. So if you are at home watching this, the calculator I recommend using is Desmos Scientific Calculator. So I'll post a link to that, but the website for that is desmos.com/scientific. Okay, so this is the one that I'm going to use as I do problems for this review. Okay, so desmos.com/scientific, that's the one I'm going to use during this review, and also that's the one that I recommend that you use on the test. It's going to help you kind of round the best, and it's the easiest way to use to get trig ratios using an online calculator. Okay, I'm going to use the online one rather than the yellow one that we use in class, in case you are a virtual student and don't have access to that yellow calculator. Okay, so to start, the first questions are related to the geometric mean. So the geometric mean, if you'll remember, is the square root of the product of two numbers. So for instance, number 1 would be the square root of 5 times 12, which is the square root of 60. Okay, so the square root of 60. Now we can go ahead and simplify that if you would like. So you can simplify that to either a decimal or a simplified radical. So if I do square root of 60, here's my answer over here. All right, 0.775. I'm going to see. Okay, it doesn't look like. All right, there's no way for that to simplify the radical for you. So just writing it as a decimal is just fine. So 7.75. You also are more than welcome to leave it as square root of 60. Okay. All right, number 2, 2.75 and 44. So again, square root of 2.75 times 44. So the first thing I'm going to do is do 44 times 2.75. So whenever I want to do another problem, I just hit enter. So 44 times 2.75. And then I'm going to type square root and put answer. And what that does is that'll just take this one, the answer that I got, and plug it in right here. Okay. And that gives me 11. So the square root of that is 11. That one is no longer a square root because it's a perfect square. So that simplified to square root of 121, which gave me 11. All right, now the square root of 5 over 2 and 15 over 8. So I'm actually going to do that, not mentally exactly, but I'm going to write it out. Okay, so on top I'm doing 5 times 15, and 15 times 5 is 75, and then 2 times 8 on the bottom. So I've got the square root of 75 over the square root of 16. Now the square root of 16 is 4, so I can take the square root of 16 and then leave the square root of 75 on the top. Okay? All right, your other option is to convert that to a decimal, and that would be, hit enter, square root of 75 divided by 4. Okay, so that's going to give me 2.17. 2.17. All right, but it is more than okay to just leave it like this. Now, you might have a problem where it says find the geometric mean. I'm going to type this actually rather than if the geometric mean. If the geometric mean of two numbers is 12, and one of the numbers is 7, what is the other number? And this is the case of we're doing a problem and we're doing it backwards. So in this case, the way I like to approach this problem is to write it as an algebraic equation, because I am first and foremost always an algebra teacher. All right, so if the geometric mean of two numbers is 12, that means 12 is the geometric mean. So the square root of 7 and some other numbers, so 7 times x. To solve this, we have to get rid of this radical. And to get rid of a radical, we square both sides. 12 squared gives me 144. And that's going to equal 7 times x because we just get rid of the radical. That's what the square does. And so then to finish, I'm going to divide by 7. So that's going to give me x equals 20 point, it's going to be 20 point something, but 20.6. All right, and I'm rounding that. So it's approximately 20.6. Okay, now the reason that geometric mean is on this test is because we use it when we have the altitude of a triangle. So when we have the altitude of a right triangle, the altitude is x. And to find the altitude, what the altitude does, remember, is it splits the hypotenuse into two parts. And I called this one part y, and I called this one part z. And the reason I called it part y and part z is because those are the legs that they touch. Now together, the two parts make a whole. And in this case, if one of the parts is 4 and the other part is 8, then the whole would be 12. Okay, now to find x, to find y, and to find z, those are the geometric mean of, in the case of the altitude, it's the geometric mean of part times part. So think about it in terms of which ones they touch. This touches part y and part z. So we do the geometric mean, so the square root of 4 times 8, all right, which gives us the square root of 32. And I'm going to leave those alone. I'm not going to simplify them to a decimal or a simplified radical unless they're perfect squares. All right, now y touches part y, so y touches 4, but it doesn't touch 8. So we don't use 8. Instead, we use the whole, which we found to be 12 by adding those together. 4 times 12 is 48, so y would be the square root of 48. Z touches 8, and then also I'm going to use 12. So that's going to give me 8 times 12, which gives me the square root of 96. Okay, none of those are perfect squares, so I'm going to leave them, but if you'd prefer to write them as a decimal number, or if the test asks you to write them as a decimal, all you would have to do is go to your calculator and do square root of 96, and then you get 9.79, which would round to 9.8, okay? And so on for all of these. So this would be 9.8. All right, and then 48 would be something close to 7, so like 6.9, and 32 would be something between 5 and 6. Okay, so that's when we use geometric mean. Now, the actual meat of this test. So most of this test, most of this quiz is going to be based on, or most of the points on this quiz are going to be based on using trig ratios. Okay, so the trig ratios, if you'll remember, are sine, cosine, and tangent. All right, and so when we approach these problems, here's how we do it. So number 14, we're looking for QR. QR is right here, so the first thing I do is mark that with an X. The next thing I do is find my reference angle. And in this case, remember, I can never use 90 as a reference angle, so I'm going to use the one that I have already marked, and it's 31 degrees. Now from there, I want to label the sides. I'm going to pick a different color just to make this very obvious. But from angle 31, imagine you are miniaturized and you are standing right here in this corner. I would describe 14 as the side that is opposite. Okay, so remember, opposite means on the other side of, so that side is opposite. And then I would describe this X as adjacent. I would describe PR as the hypotenuse, but I want you guys to remember that I only want you to label the side that you know and the side that you need to know. And the reason for that is now the next step is to pick which trig ratio I want to use. And that's going to be easier if I only have 2 letters on there, because that's what's going to tell me which trig ratio to use. And I don't want to get myself confused by having all 3 letters when I only need 2 to identify the trig ratio. Okay, so I have an O and an A, which means I'm over here in this part of SOHCAHTOA, and that stands for tangent is equal to opposite over adjacent. So I'm going to be using tangent. To set up my proportion, tan always goes with the angle. All right, so tan 31 equals opposite over adjacent. So in this case, 14 over X. This isn't a fraction right now, but if I want to make it a fraction, I just put it over 1. And now I can go ahead and cross multiply. So start with the easy part. What's 1 times 14? Well, that's 14. And then now the other part of the butterfly method, if you're thinking about it that way, I just always use an X rather than circling them because I don't know why, it's just my habit. All right, so I'm multiplying tan 31 times X. And remember guys, I'm gonna go really quickly to the calculator and show you tan 31, if you remember, just represents a really long decimal, okay? So it is a number, but I don't want to write that whole decimal out, so I'm just shortcutting it by writing tan 31, but remember it is a decimal number, okay? So tan 31, don't let it freak you out, it's just a number, but this is a shorter way of writing it, okay? Now, how do I get rid of anything when it's multiplied? I divide, so I'm going to divide by tan 31. And if I do it on that side, I have to do it on this side as well, okay? On the right side, tan 31 divided by tan 31 through the magic of algebra is going to cross out, and I'm left with only X. And then here's where I go to my calculator, 14 divided by tan 31. So remember, in this case, 14 is going to come first, divided by tan 31. And this is where I highly recommend, guys, that you are doing this on this scientific calculator. If you're trying to do this on the calculator on your phone, it's not going to work, okay? So I really recommend using this scientific calculator for this. Your answer is 23.29. The 9 means this rounds up to a 3, so 23.3. All right, is approximately the value of X. Okay, I'm going to do the next one. So the first thing I want to do, I'm looking for AB. So I put my X and I swoop around my reference angle. This is my reference angle because it's the one that I know. I'm going to work a little bit faster on this one. All right, so now I'm going to label the X is going to be adjacent to the 50 degrees. And the 6 is going to be the hypotenuse. I'm not going to label this one because I don't know it and I don't need to know it. Okay, so I'm not going to put the O down here, even though this is opposite. I'm not going to put it because I don't need to know it and I don't know it. So it's not going to help me pick my trig ratio. Now I see that I've got AH. So now I'm talking about this trig ratio, which is cosine. So I'm going to go set up my trig ratio proportion, which is cosine of 50 over 1 equals adjacent over hypotenuse. All right, so now in this case, I'm going to start with 1 times X, which is X. And then on this side, I've got cosine of 50 times 6. All right, so I'm actually already ready to get my answer. I don't have any division to do because X is already by itself, so I'm ready to take this to the calculator. Cosine of 50 times 6. If you'll remember what I said previously, when you are doing these problems, I highly recommend always starting with the whole number 6, because then if you don't close your parentheses, it doesn't matter. All right. Whereas if you do it like this, cosine 50 times 6, and you forget to close the parentheses around the 50, it changes your answer completely, okay? Because this is like doing the cosine of 300, and you don't want the cosine of 300, you want the cosine of 50 times 6. So my recommendation is always just put the 6 first. That way, even if you forget to close the parentheses, it's still going to give you the right answer, okay? And the right answer in this case was 3.9 approximately. All right, last but not least, let's do this problem over here. So here's my reference angle. My unknown is LM, which is this one right here. Now this triangle is in a little bit of a weird position, but we can see that this right here is across from the 90-degree angle, which means it's the hypotenuse. And this one then is across from the reference angle, which means it's the opposite. So I'm talking about trig ratio sine. The sine of 62 over 1 is equal to opposite over hypotenuse, which is 4.2. All right, I'm going to cross multiply. I know I'm working a little bit quickly, but that's because I'm on my third one. All right, X times 1 is X. Sine 62, actually, let's get in the right habit. 4.2 times sine 62. All right, I already have X by itself, so I'm ready to solve this by typing it into my calculator. So 4.2 times sine 62. So I hit enter and I do 4.2 times sine 62. All right, close parentheses or not, my answer ends up being 3.7. Okay. All right, so whenever you're looking for a side, remember that's when you're setting up a proportion. Now, for the next part, this is the last part. This is kind of putting it all together. So in this case, we're going to find the unknown measures. I'm going to do 17 and maybe 18, depending on how long this video gets, but I might leave 18 and 19 for you guys for practice, okay? So I'm starting here with number 17. And the first thing I want to do is find the unknown measures, which means I'm not just finding one, I'm finding all the sides and all the angles. What this means is I'm going to have to use trig ratios to find not only sides, but also angles. So to do that, I'm looking at number 17 and I want to identify what are the things that I need. So the first thing I see is I need the hypotenuse, AC. All right. I also need CB. I do not need angle C and I don't need angle B, but I do need angle A. All right, so let's start with AC. I'm going to label that X to start with. Here's my reference angle, 32. I can see from here that I've got the opposite and the hypotenuse. So now I'm talking about sine. All right, I'm talking about using the trig ratio sine. Since it's a side, I'm going to set up a proportion. So the sine of 32 over 1 equals opposite over hypotenuse. Okay, start by doing 1 times 22, which gives me 22, equals sine 32 times x. Divide by sine 32 on both sides. Okay, this one goes away, and I'm left with x equals approximately 22 divided by sine 32. So 22 divided by sine 32, which gives me 41.5. 41.5. Okay, so that is the hypotenuse. So now what I'm going to do is I'm going to erase and just label this 41.5. Okay, I'm going to erase the O as well. Now, the next thing I'm going to do is solve for CB. So I'm going to move my X. This is still my reference angle. All right. Now for CB, I can use either one of these, 41.5 or 22. I'm going to stick with 22 because it worked for me before. So that's opposite the reference angle. And now I'm looking for X, which is the adjacent. I'm not labeling this one. Even though I know it, I don't need it. I already have 2 letters labeled, so I don't want to do a third because that's just going to confuse stuff. So OA tells me that I want to use tangent. Since I'm doing a side, it's going to be a proportion. So tan 32 equals opposite, which is 22, over adjacent, which is X. Okay, so now I've got tan 32 times X on the one side and 22 times 1 on the other. So that's equals 22. I'm going to divide by tan 32. This is just like the one that we just did. The difference is instead of using sine, I'm using tangent. All right, that goes away and I'm left with X is approximately 22 divided by tan 32. So 22 divided by tan, and I'm just typing this in because that's why this calculator is the best. Okay, that's 35.2. All right, so this became 35.2. So now we have both of our sides, and now we need to find an angle. So I'm going to label the angle that we need, which is A. I've got all 3 sides, so I can use trig ratios to figure out this angle, and I'm going to do it that way. And then I'm going to talk in a second about a different way we could have done it, but I want to focus on how to use trig ratios since that's what we're doing here. Okay, so I'm looking for angle A. Pick 2 of the sides, any of them, because we already know that we have angle A and we have all the sides. So I'm going to pick this one because it's a whole number, and this is adjacent. All right. And now I'm going to pick this one because I like the color blue better, and that's opposite. Okay, I'm ignoring the 41.5. I could use it, but I'm not going to because this is the one I chose. If you had done it, nothing would change here except your trig ratio. Okay, remember when you're finding a side, you use a proportion. When you're finding an angle, you use an inverse. So if my side is opposite and adjacent, then I'm talking about the trig ratio tan. So that means I'm going to use inverse tan, which is tan -1 of opposite 35.2 over adjacent, which is 22. All right, the best part about finding angles is as long as you remember to use the inverse, it makes all the heavy lifting on the calculator. Okay, I'm going to clear this to give us more space. If I want inverse, I go right here. Okay, so I go to function on my calculator and I think it was inverse tan of 35.2 divided by, I just hit the slash, all right, divided by 22. And that's it, 57.99, which rounds to 58. Okay, so that angle is 58. Now, some of you might be thinking, couldn't I have just added and subtracted to get that? And yes, you absolutely could have. You don't have to do it this way. I just like to remind you guys that we have that inverse available to us. Okay, now, that's not always going to work. So let's do number 18 together. And then I want to leave 19 for you guys to practice, okay? So for number 18, we have a couple unknowns. We have angle, let's start with the sides. We need to find HJ. All right, so we need to find side HJ, we need side H, angle H, and angle J. All right, so I need 3 pieces of information here because I already have 3. I have side HK, side KJ, and angle K. I don't have a reference angle. I don't have a reference angle right now because 90 degrees can never be a reference angle. So before I can solve any of this using trig ratios, I need a reference angle, which means I need to figure out either H or J first. So to do that, just pick one. It doesn't matter. Flip a coin. I'm going to do H first because I wrote it first. So I'm going to mark that. From here, I'm going to label the 2 sides that I know. So I know number 7, which is adjacent. And I know 10.5, which is opposite. HJ is the hypotenuse because it's the longest. I'm not going to label it because I don't know it. So it's not bringing anything to the table for me, okay? So now, as always, I'm going to write SOHCAHTOA up in the top. All right, and what are my 2 letters? O and A. So I'm going to be using tangent. Remember, I'm looking for an angle. So I'm using inverse tangent of opposite, which is 10.5, over adjacent, which is 7. And again, the good part with angles is if you know how to do it, if you remember that it's inverse, you're literally not doing any work. You're typing it all into your calculator. So inverse tan, which is right here under function. Okay, so here was our main, then we have an alphabet keyboard, and then you have function. Function is where you're going to find inverse tangent, okay? And it was the inverse tangent of 10.5. So I'm just typing now. Whoops. Make sure you're inside those parentheses. 10.5, and then I hit slash, and it makes it a division problem over 7. I think it was 7. Yes, 10.5 over 7. And that gives me 56.3 degrees. I'm actually just going to round that to 56 because it tells me to round the angles to the nearest degree. All right, so that's 56 degrees for angle H. So I'm going to put that right in there. All right, now I'm going to do angle J also using a trig ratio. Okay, so trig ratio for angle J. What's going to change? Well, remember when we talked about reference angles to begin with, I said, okay, if I'm standing in a room, the ceiling is above me. But if I go up on the roof, now the ceiling is below me. So the ceiling didn't change position, but because I changed position, my perspective shifted. So that means I'm going to erase A and O because if I'm standing at J right here, then that means 10.5 is now my adjacent and 7 is now my opposite. So my opposite and my adjacent shifted. However, I'm still using opposite and adjacent, which means I'm still using tangent. And since I'm looking for an angle, I'm still using inverse tan. And now you're thinking, how is this going to be any different? Well, look, inverse tan of opposite over adjacent would be 7 over 10.5. So we can see that this is something totally different. Even though it's using the same numbers, 10.5 over 7 is not the same as 7 over 10.5. But again, I'm already ready to go to my calculator. So I'm going to use inverse tan of 7 over 10.5. And that gives me 33.6, which I'm going to round up to 34. So angle J is equal to approximately 34 degrees. All right, which is great, because if I check that, I can see that those all add up to 180. Okay, and then we're ready to finish this problem by finding HJ. So I'm looking for the hypotenuse HJ, so that's my X, and I'm gonna immediately label that H, because that's my hypotenuse. And now I need to pick a reference angle. Well, I left H marked with a little swoop, so I'm going to use that. So X is the hypotenuse. H is marked with the little swoop. I have a choice. I can either use 7 or 10.5. Since 7 is a whole number, I'm going to use that. So that's adjacent to it. So I'm going to use AH, which is cosine. If you had preferred 10.5 and used O, you could have used sine. All right, that's fine. But either way, we need to use sine or cosine because I need to find the hypotenuse. If you'd done tangent, you would have had both of the sides already and wouldn't have helped you. Okay, so for a side, I'm setting up a proportion. AH tells me I'm going to use cosine. So cosine of 56 degrees over 1 equals adjacent 7 over hypotenuse, which is X. I'm going to cross multiply, start by doing 1 times 7, which is 7, and then cosine 56 over 56 times X. To finish this, I just divide by cosine 56 on both sides. Sorry, I have a little less space over there. All right, here, that crosses out, and I'm left with just X. And on this side, I'm going to go to my calculator and do 7 divided by cosine 56. All right, and I get 12.5. So it's approximately 12.5. Okay, which makes sense because the hypotenuse should be the longest side. All right, so if I'd gotten something that was smaller, I would have known that I'd done something wrong. Okay, so my best advice for you from here to continue to prepare for this quiz is to do number 19. So find all the missing parts. If you can solve this right triangle, you can do anything on this quiz. All right, and that's it for the review.